So, you want to build a quantum computer to solve some special problems unbelievably fast? Well, then you need 3 things. 1. Quantum bits or qubits. 2. A way to control these qubits and to have separate qubits interact. 3. You need a flexible way to program operations to run different quantum algorithms. We at QTech have built a quantum chip in silicon that works at a temperature of 20 millikelvin, has controllable qubits and is, for the first time, fully programmable. A quantum bit is a quantum mechanical system that can be in 2 states at once. A famous example is Schrödinger's cat, which can, strangely, be in a superposition of dead and alive. However, cats are very impractical for this purpose, and we use electrons for our qubits. These electrons can spin in different ways. When the spin is in this direction, we call it up, and the qubit has value 1. The other direction is down, or 0. And like Schrödinger's cat, the electron can also be in a superposition of up and down. On our quantum chip, we store the electrons in quantum dots, which act like tiny pools for the electrons. One way to control the qubits is to change the direction of spin with precise microwave pulses. The nice thing about our design is that we can move the electron pools. When the pools are close enough, the electrons will start to feel each other, so they can interact. For example, you could make them do a conditional rotation, which means that one rotates, but only if the other is up. All operations have their own symbols. Some are 1-qubit operations, others involve 2 qubits. A quantum algorithm happens by stringing these operations in a particular order. One of the simplest quantum algorithms is the Deutsch-Jozsa algorithm, which checks whether a coin for a coin toss is fair. If a coin has heads on both sides or tails on both sides, it's fake. But if it has heads and tails on either side, it is fair. For a fair coin, the quantum algorithm returns 1. For a false coin, it returns 0. Now, to be fair, this is not very impressive, and it's not supposed to be. The algorithm has been invented to show that quantum algorithms can work faster than any classical algorithm when things scale up. If we don't work with a coin with 2 sides, but a die with a million faces, a quantum computer with enough qubits can still check in one step whether all faces are identical or whether the faces are half-half, zeros and ones. A normal computer would have to check the faces one by one. With our controls, we could run the 2-qubit Deutsch-Jozsa algorithm and another quantum algorithm by programming different operations in different orders. And although our processor has only 2 qubits, it is made of silicon, the material of regular computer chips. There is already a tremendous experience miniaturizing and extending these. So our fully programmable quantum chip may be small, but it is an important step for scaling up to 10, 1,000, 1,000,000 qubits or even more, to build a quantum computer that can do useful quantum computations.